well. So just give you an overview of our training. Typically, it runs 3 to 4 sessions. We will go through basics during those training. So we go from single unit cases to partial cases and fully edentulous cases. And
yeah, hold on 1 second. Where we could barely hear you here actually on our end. I mean, my volume's all the way up. And
I think my volume is pretty high already. Let me check.
Okay, Doctor, could you record this meeting?
but he needs to give us permission.
Oh, okay.
So can everybody hear me, or just Doctor couldn't hear me well?
I can hear you.
Very, very low.
Yeah, it's very low.
Very low. If you look at my microphone here, it's pretty.
How do we turn the volume?
The volume is pretty high.
It's maxed.
Okay.
Unless we could run the audio through our telephone.
And I'm just using the speaker of and the microphone of the computer.
Oh, let's turn this up here. Hello?
Yes.
Okay, we figured it out on our end.
Okay. So are we good to go?
Yeah, we're good to go. We're wondering if you could record this lesson.
Yeah, I'm actually I'm recording already.
Okay, perfect.
And
okay.
also the last time I had some session recorded. If this doesn't work, I'll send you that one.
Okay.
Okay. So just for the training, as I said, we will go through 3, 4 sessions, depending on your progress. And we arrange the training by your pace. So when you feel comfortable, move to the next level, we'll do that. And in the meantime, this program, this guided surgery area is actually a very heavy support. So we are always available for supporting. So whenever you have any questions, just send me email or send me a text message with screen captures. Majority of the time, I would say more than 70% of the time, I can just take a look at a picture and get back to you with right answer. And if I'm not available, we have our other team members available. So just feel free to email whenever you need assistance. Then let's start with a simple case, So we start the software, and if you look at your screen, my screen here, there's a team viewer button. So we don't have to use Zoom. When you are running your software, if we are online, if we're online both ends, we can connect with TeamViewer, and we can get onto your computer and show how the software works. Now let's start a new project by selecting the patient DICOM file. I have something here. So I will do a single unit case. By looking at my patient CT scan. So typically the patient CT got a couple of hundred files. If you look at those files, they all come with .dcm on the end of the file name, meaning that's DICOM file. If you sometimes the CBCT doesn't generate files with this .dcm, they come with no extension name here, then you can just click on this, showing all files. It's going to show everything, and you will see the DICOM files. So among those files, select anyone and click open. It's going to open all the files.
Now, opening,
So the first thing is to click on a new project, correct?
Yes.
Okay, so that's the first tab on the upper left-hand side, if I remember where it was located. Okay.
and so so we have all of the DICOM files saved in a folder, DICOM and STL files saved in a separate folder?
Actually, yeah, you better put them onto a same folder.
Put them in the same folder, okay.
Yeah. So now we open the DICOM files. This is a workflow panel of your system. And we have 5 graphics windows, 3 car sections, and 2 3D windows. And this window is for the object we are working on. And this is for all the objects we have in the workflow. If you look at all of those windows, they come with a toolbar here. So a couple of things here. The first button in all of those windows is to make the window
Okay.
bigger or smaller. And those dividers between the windows you can drag.
Each window has, when you hover over the window,
Yes, when you go into the windows, the toolbar will pop up. Then, so that's to make the window bigger or smaller. And for all of those windows, right mouse button to zoom in and out. You just press the button and move your mouse. It's going to zoom in and out. That's a right button. Left button is to rotate. On the 3D windows to rotate. Of course, on the 2D windows, you cannot rotate the slices. So what's happening for the left button is we change the display of the 2D windows, which you can say it's contrast and brightness. You see that? Or in the city world, we call it threshold or Hounsfield unit values. We are.
okay, excuse me. Could you backtrack?
You need a mouse.
Yeah, we don't have a mouse. I have a mouse, but we have to
Yeah, that's not paired.
log it to, we have to pair it. Could you review what the threshold and Hounsfield?
Yeah, he's just changing the.
Could you review that for us?
Yeah,
'Cause
he's
some
just
people
moving
don't-
left and right. That
Yes.
changes.
So if we look at the lower part, the corner of my screen, now it shows HU minus HU 179, right? That's Hounsfield unit of the city pixel. For each pixel, we have a value. Typically, it ranges from minus 1,000 to a couple of thousand. For some CBCT, they got a different range, but most likely you get from minus 1,000 to 5,000, something like that. This Hounsfield unit value is basically reflecting the material density. So if we move to the teeth, you see the value is 2,157 now. So
Oh, gotcha.
meaning this high density material. Air is minus 1,000 supposedly. This one got minus 278. So for water is 0 typically if the scanner is collaborated properly. Water is 0, air is minus 1,000, and teeth are a couple hundred to a couple of thousand. So that's a Hounsfield unit value. When we display the slices, we can select to display some of the pixels. So if we look at here, minus 745, and high value is 1406. That's the range of the pixel of we are showing. If we go higher, meaning we want to show all the pixels from the whole entire range, then everything shows up here. But in the meantime, you see the contrast is getting lower. So it's not so bright because we are trying to show the entire range from minus to about 10,000. When we are showing more pixels, a more bigger range in the city, in the cross sections, we see lower contrast. So when we go lower of the high value, the contrast get bigger. So we see they look like more brighter. And in the meantime, I go higher. You see here we are losing the soft tissue if I go higher. We only see the bone and teeth. So that's how you adjust the display with the two sliders. And in the meantime, if we put on our mouse on here, just do left up and down, that's to change the level. I'm going to explain the level thing. And left and right is a window. So basically, when we have those two threshold value, low value and high value, so that's like a window, right? A range. So the average value of this, the average, the middle value of this is what we call the level. So it's like when you show, let's say this is a chart, you show from this value to this value. So the middle one is the level and the range is the window. So if I put my mouse back to the graphics window here, look at the lower part of my screen. It shows you window level 3590. That's the window. Level is 1600.
Oh,
So
right here.
it translated to threshold minus 147, and higher value is 3000. So that's, I'm sorry?
Could I ask you a question? Like,
Yeah.
what is the purpose? I understand that Hounsfield units, density. What's the purpose of this? Of looking at these different levels?
Okay, so when you got the CT, right? That's everything you have in the CT, right? You got the bone, you got soft tissue, you got air, right?
Yes.
This is everything you have in your CT. But you don't want to look at all of those. You only want to look at the bone structure.
Okay.
Right? Now you still got soft tissue. Now we only get the bone structure here.
Gotcha. Okay.
So that's the purpose of doing that. We are filtering the pixels so we see specific range of the CT scan pixels. So we want to look at the bone, we want to look at the high density area, and then we adjust this value. Then if we want to look at the low density area, then we go lower. So using this two slider or use the mouse on the windows, they are the same thing.
Okay.
We can control what we want to show on the screen. So typically first time you load the data, you go like this. Then on the 3D window, you see everything. That helps you to look at the implant site to determine what to do, your treatment time, planning time. So that's the overview of the case. By the way, I realized I didn't help set up your machine yet. We'll do this later. So we take a quick overview of the case and we know this is the implant site. Right? So
Yes.
let's look at a couple of other things on all those windows. We're talking about left window to rotate on the 3D, left button to rotate on the 3D window, and left button on the 2D windows to change the threshold. And another one is middle button on your keyboard, on your mouse. Or if you don't see the button, the wheel on the mouse is actually a button you can press. So we press and move. That's to pan the view. Just move this objects within the window. That's another operation on the mouse. And the mouse wheel, if you put your mouse onto the cross-section windows, you rotate the mouse wheel, you actually go from one slice to another. So if you look at on this corner view, when I am moving my mouse, so we are actually cutting the slice, right? It's like moving this box up, back or front. So in the meantime, if you look at this cross-section view, this brown line, or the vertical line, is actually where we're cutting the data. So this line is corresponding to this box. So in other words, if I drag this line, say this is change. Similarly, this blue line, the vertical blue line, is corresponding to this cross-section. So I can drag so that we cut the sagittal view from the different position. Similarly, if I go this, I'm going up and down on the axial view. And in the meantime, double click your left button on any of the views will take you to that spot. For example, if I double click on here, you see, it takes me to the tip on the sagittal view, on the axial view, on the corner view. So that's the double click. If you want to look at this spot, double click here, you go here. And if we want to, for example, we want to look at the mental foramen here, you double click, it takes you to here, see? So all those image views are associated with this. Then on each of the toolbars, the last button is to go zoom in and out. So when you got everything, for example, you zoom it out all the way, in all the way, then you do this, it will take everything into the view. So when it's too big, you do that. So it will come back. So that's the last button. And another one in all of those windows is this red button, red dot, is to record movie. So everything happening with this window can be recorded after you turn on this. And after you finish, it's going to generate a movie file, which is an AVI file. We'll show you how it works later.
Okay.
All of them have this recording button. And now we look at the workflow panel. This is a full-fledged workflow. It has everything in the system. So if we look at here, the first page is case preparation. The second page is treatment planning. Snapshot and bookmarks, we can capture pictures. Object manager, we manage all the objects, data sets we create during the workflow. Surgical guide design and reporting. So that's basically the workflow. You go step by step. But for beginners, there are so many functions in this workflow. It could be a little bit overwhelming. So what we have here is we have this GuideMia Express wizard. This is a step-by-step guide. So today, the first thing we're going to do is we're going to use this wizard to run through the case for both edentulous case and fully, partial case and fully edentulous case. And the next time we can, in the meantime, we will explain the workflow panel here, find the corresponding functions between them. And the next time we will gradually move onto this full workflow so you can explore additional functions. So let's go here. First of all, we need to select our case type. That's, for this case, is a partial case. So we have optical scan with CT, and it's lower jaw case. So select this one. Then go to next.
This is the STL.
Now, the first thing we do is bone segmentation. By segmentation, we mean to get a piece of the bone structure, which is interesting to us. We want to work on that piece. So for this case, that's the lower jaw, right? So in order to get the lower jaw on this CT data set, the first thing is we want to change the size of the box. So you see here, we get the lower part of the jaw. And we don't need the higher part. We can go lower on those boxes. And if you feel we have too much on the back, we can drag this handle. So that we,
and doing this, if you don't need the data, so you won't get slowed down in the program?
what do you mean? You don't need the data? Is this just?
Okay, yeah, I mean, I know in Blue Sky Bio, you reduce, you get rid of the information you don't need because it optimizes the program.
I'm not sure what you mean. For us, there's one thing. On the cross-section views, we never reduce the data. We keep everything. So that's for the purpose of safety, of maintaining all the data. On the 3D windows, we do cut. Well, this is called the volume of interest. We only get the area we want.
Okay.
Yeah. So the first thing is to adjust the volume of interest. The second thing is to adjust the threshold. So we go higher or lower. You see here, right? So at this moment, as we talked before, we have two values, the lower value and the higher value, right? But for the treatment planning purposes, we take everything higher, everything in the upper range. So we only actually adjust one threshold, which is a lower value. When I adjust this, on the cross-section views, everything above 581 will be shown as red or white. So if I go lower, you see I'm getting soft tissue into the windows, right? I go even lower, I got more soft tissue. But if I go high, I'm losing the bone structures, the soft bones, I'm losing those. I only get the cortical bones here. So you need to find the perfect, optimal range. So when you go to about 500, typically 500, 600, 800, you see you are not getting the soft tissue and you are not losing the bone structures with cortical bone. So that's probably the best range you have. So that's the second thing. We adjust the threshold value. So you need a box, you need the threshold value, and the third thing, you need to pick a piece. You see here we have lower and we have upper. We only need the lower, right? We need to pick a piece.
So you have to adjust this threshold for every case.
Yes, because every patient is different. So
some patients have more denser bone than others. So you have to play around with that until you get to this sweet spot, which is.
You have to do it for every case. I mean, if you have a recent extraction site in the maxilla, you're gonna have really less dense bone. So you want to lower this value. So you start picking up that bone. If you have
exactly,
you're gonna lose it.
Okay.
Yeah. So three things: the box, the threshold, and the piece you want. So by doing that, we use this. We need this seed point button. We click on this, telling the system I want to pick a piece. So I go to my sagittal view, I pick on the lower jaw. I can pick on any area on the bone or on the teeth. So I pick a point. I don't try to pick from, for example, this area, because it's on the boundary between the bone and the missing filtered out area. So I want to be somewhere really solid. I pick a point here. So I get rid of the upper piece. So for the this imaging processing, this is called region group. Basically, the idea is you pick a point, you grow your region, you find all the pixels connected to this point. That's called a region group. But for us, you just need to remember, you need to set the box, change the threshold, and pick a point to pick the piece you want. There's an additional function here called tissue pinning. That's for, typically it's for fully edentulous cases. We'll show this next case. But here you don't need that. Then we finish the bone segmentation. We have a nice clear bone structure here. Now, scatters, majority of the time, you really don't need to deal with them because they exist. You can cut, but unless you want to print the bone structure, you can clean up it. Otherwise, it doesn't help if you do, even if you clean up it. You will just leave it alone. Then, of course, we have the functions to do so. If you look at what we have on here, we are on this segmentation page. So you see there's a threshold value here and here. We have set points, and we have scatters functions here. So we do have all the functions you need to clean up the data. But let's focus on core workflow for a moment. We go to next. Now, since we have the patient CT scan, we will need to get the STL file of the model. So we load the STL file. Yep. And we find the STL model. And we open it. Now we have the two data sets here. Before I try to register them, let's talk a little bit about case preparation, about scanning protocols for implant guided surgery. So in general, when we are doing this treatment planning for clinical reasons and for technical reasons to design surgical guides, so for both aspects, we need a full anatomy of the patient, meaning you want patient's bone structure, you want to have the nerve structure, you want to have the soft tissue, the teeth, and the occlusion too. So no matter what you are doing, for clinically and technically, you want to have all those information. So then you want to put them together into one coordinate system. Right now, if we look at the data set, they are not in the same location. So we need to put them in the same location, align them, in other words, so we have a complete anatomy. So the reason I'm talking about this is here. So
could I ask a question, please?
yes.
So you imported this STL file. Now, do you need to trim this model up before you import that?
No.
Okay.
Yeah. Yeah. We'll get into that part.
Okay.
So for the moment, so for technically, as we know, CBCT can only get you clear picture of the hard tissue, right? You cannot get the soft tissue.
Sure.
Clearly. The optical scan or intraoral scan, they give you the soft tissue, they give you the tooth surfaces very clearly, but they don't give you the bone structure. So technically at this time, we still have to combine the two modalities to get our information.
One question
Yeah.
for the CBCT data. What voxel size do you prefer for for these programs? Because most machines will do some sort of a high resolution or low resolution. What type of voxel size do you require?
Typically, nowadays the typical values we see are something like 0.2, 0.15, or even lower. They are all good. We say 0.15, 0.2, 0.3. And here is the thing for the voxel size. There are two values. One is the native value of the machine. So the scanner itself, physical capability, only just, for example, 0.4, right? Then the software in the machine, they can do interpolation, and then they tell you the value is 0.2. So they double the size. But actually, the native value, physical value, is only 0.4. And they tell you a higher resolution by, a mathematic approach. So typically, nowadays, I think most commonest numbers we have seen are 0.34, and after the interpolation, you get 0.15, something like that. But we do require better resolutions, so the thickness shouldn't be more than 0.5.
Not greater than 0.5.
0.5 is the upper limit.
Yeah, we cannot go lower than that. Even on the early days, the people are doing that, but no.
Do you think there's any machines that low? The new ones.
Yeah, but typically, all the machines are now good enough. So let's come back to this scanning thing. So the idea here I want to say is, as long as you can get all the anatomic information, you are good. So meaning you can combine different ways to scan. Let's look at what we have on the full workflow panel here. The first page, you see here we have radiographic guide. We have stool model. We can take an impression CT. So those things are supported with our system. We can, in other words, anything you can use, any means you can use to contain the anatomic information, you can scan them and align them together. So that's what I want to say. So,
so if you were doing a dual scan, we would so we have some fiducials on the denture. We scan the denture. We would probably which one of these would be used?
Yeah, for here that's a radiographic guide.
Okay, you would use a radiographic guide. I got you.
Yeah. Actually, as I said, you because as long as you have all those information, we can do radiographic guide. We can of a CT scan with a CT scan. You can also do an optical scan of a radiographic guide, or just a digital denture design. So whatever you have, we can load into the system as long as we can register. So Dr. Berger's question, do you need to trim and make clean the model? The answer is, for treatment planning for surgical guides, we don't need that. We never did that. Only if you want to export the model so that you want to do additional work. For example, in our system, we can create a model with implant holes or with analog holes on it. In that case, of course, you need to fix and close the solid model. But for the planning purposes, we never do. So we'll just load the file and go to next step.
That's great.
Now, if you look at here, we want to rotate the view. So we see the both window in about the same orientation. And this is to register them, just to put them together. If we,
excuse me, can I ask a question?
yeah.
The is this scatter we see that, is that just due to the voxel size, or is that just due to maybe the patient has metal in their mouth?
Mostly it's a metal, not voxel size.
Okay.
Yeah, those are restorations. So for, yeah.
The scatter here that we see?
Yeah, those are the metal things.
When you scan the patient, it bounces.
Yeah. So yeah, going back to scanning, we recommend to have at least 4 natural teeth for partial cases, if we want to align the models with the CT. If they have all metal restorations or ceramic restorations, they don't have natural teeth, then very likely on the CT scan, you will see scatters everywhere. And there's no way we can simply align them. In that case, we need to make a radiographic guide for the patient. So the guide will not like a denture, but just like aligners, just cover all the teeth or retainer. So that's a little bit about scanning protocols. For such a case, to align model with CT, we need at least 4 natural teeth.
Okay, so
ideally surrounding the implant site.
I got you. So I mean, I have a patient right now. I mean, you know, she has every tooth in the head has a crown on it, and we need to do some implants. Okay, she has no missing holes. She has no. She every tooth has a crown. And I need to do an implant on numbers 8 and 9, but the teeth are still in there. All right. So I mean, what do we do? Do I, you know, what I have the.
We make a radiographic guide.
But I can't make it. They have no teeth missing.
Let me find a document. I'll send you that later. I'll show you that.
Less than 4 natural teeth. That's what I'm saying.
That I understand. I'm just trying to figure out this one.
So we have this radiographic guide protocol from Nobel Biocare. It's pretty much a standard approach. So this is for the fully edentulous cases. You basically have something like a denture, right?
Yeah.
Then for partial cases, you do this.
No. I understand that, but all right, you know, we do this already. But the situation I'm telling you, so the patient has every tooth, so she has from 3 to 14.
Yeah.
And all of them have restorations. There's a crown on
okay. So at the surgery time, you need to do immediate extraction and then placement, right?
Correct. So
yeah, I'll get to that. I'll get to that with this case.
Okay.
So now let's go back here to register the 2 data set. So what we do is click on the specify markers, then pick points on the CT scan and on the model. The order doesn't matter, but typically we go in the same order. Now there's one thing I want to mention. If I pick a point here, I purposely pick a different location. It doesn't matter. So within certain range, 1 millimeter also, it doesn't matter. We still can align them. So you don't have to worry too much and to be very careful to select the points. As long as they are within 1 or 2 millimeters range, it's fine. So I pick those points, I click on this align button, system will align them together. And then it's going to tell us we have a deviation about 40 microns among those areas. So this value is the deviation between those three areas, not the entire arch. There's no way at this moment we find the value for the entire arch.
What is the unacceptable deviation?
Typically for partial cases, we are looking at 100 microns
Okay.
or 150 microns. For radiographic guide, we're looking at 200 microns. Now you see here we align them, right? And as I said before, on each of the window, if I double click this, it's going to take us to the others, to the slices, all the 2D cross sections to this point, right? Now the reason I'm doing this is so I can find the location to evaluate how well the alignment is.
Yeah.
So this is a tissue and this is a tooth structure. So you see how well they are aligned with each other. It's pretty good, right?
Yeah.
And here too, if we go up and down, use our mouse wheel to scroll through the slices, we can see how well the model scan follow the CT data, the bone, the teeth. So it's very well, right? So that's a very good alignment. And let's go back here. If you don't like it, you can click on this reset button and redo the process. And for this case right now, we're happy with that, so we don't have to do it. Now, there's another button here to take the add a prosthesis or antagonist scan. If we have the operator scan, or even if we have a wax up, as long as they are aligned, then we can load them from here. So for this case, I'm going to load my operator scan. If you remember what I said earlier, I said both technically and clinically, we need a full anatomy, meaning tissue, bones, teeth. I purposely said also occlusion. So this is where it plays a role. We need the occlusion for the purpose to have a good treatment plan. So we load the upper scan here, so that we can, when we place the implant, we can check the occlusion.
Yeah.
You see here on those 2D windows, we are not showing this purple model. As I said earlier, this is our assembly window. Now you see we have three things here, but this is our working object, right? Now, right click on this mouse, this window.
One second, does this how do you know the bite on this patient?
Yeah, here's the thing. When you scan the patient's model or do intraoral scan, you're going to scan the bite. The scanning software will put them together. So when we transfer it into our system, the antagonist scan will just follow the preparation. So for this case, the operator just follow the lower jaw.
Okay, so basically, so once we scan the upper and lower one, we scan a bite, which we typically do, that gets saved. Once we send the STL of both, all right, it's saved somewhere, and then GuideMia, when you import the two, it would immediately put it into the occlusion that you captured on your intraoral scan.
Exactly. So now we have the occlusion, and then we go to, now here, if you right click on this window, any object, then you will see we have a couple of functions showing up here. The first one is show height datum plane. That's an occlusion plane. So we can define a occlusion plane, but for now, we are not doing that. So I'll just hide that. Go back here. So we can hide this object, or we can show this object. We can show this object in the 2D cross sections. Now you see here, we are showing them on the 2D cross sections. And you can change color. You can move this object around. For this case, of course, we don't want to do that. And we can make object current. This function means we want to work on the object. We want to show it here. For example, if I right click on the bone structure, I say make current, it's showing up here.
Oh, gotcha.
Yeah. So other things, for example, if when I put it here, I can change the color, or I can, for example, I can clip this to look inside the structure. I can rotate this clip plane. So do evaluation, and maybe I can record video, etc. So you can always set an object as your working object. Now we set this view, we display the model antagonist on the cross sections. Then we go to next step. That's to create the nerve. So we can directly go to the next step, or we can actually adjust the arch curve before we go. So right now it's generating the panoramic view. And you can turn on and off the panoramic view with the button on the toolbar. The reason we have this is, look, right now if I want to adjust my arch curve, this is what I typically do. So because we are trying to draw the nerve channel on the lower jaw, and we know the channel is about this level, roughly. So I drag my cross-section line, the green line, to here, meaning I go to this level at the axial view. Now at this slice, I adjust my arch curve. I don't do it at here because it's far from the nerve level. So we do it here, close to nerve level, and now you drag the entire line on the green part, or you drag the red dot, drag the handles, so you can have a different curve. So you see, when I do this, this view is being updated. It takes a bit long time because we are re-slice the entire data set to generate the panel. If you want to do faster, you turn off this view, turn off this panel mode, you do everything here until you are happy with the cross sections, then you go back. This way you only, the update you only does once. So that's to prepare our panoramic view for the nerve. Now, we only do the left side of the patient.
Yeah.
And here's how we typically do. We find the mental form on the 2D view, on the 3D view. You double click, it takes you to here.
Okay.
Or of course, you just go to the slices to find the point, right? You can always do that to find the mental form here. That's to find the entrance. Then we click on this button to start with. We click on this. Then I will pick one point from either the sagittal view or the corner view. For example, I start from here. You see at a point here?
Yeah.
Then I can go in and we create part of the channel already here.
Yep.
And we go back to the corner view. We go back and forth to look at the channel. So here's the channel. And in the meantime, we notice that it goes to the medial side a little bit, right? You can either create a full segment or you create two segments. So let's say we want to create a two. So we go to the distal part first. We find the channel. We can go a little farther. We keep using mouse wheel to rotate, find the right slice back and forth. And then we use left button to add a point. And finally, we click on right mouse button to finish. Remember this, you use right button to finish. Now we finish the left channel on the major part of the channel.
So you left click to start,
Yeah,
and then right click to finish. Okay.
yes. As I said earlier, there's a little segment on the medial part. If we want to
There's
create
actually
that,
a loop there. Yeah.
we click this button again. We add additional segment as you like, and right click to finish. Now we have this
Oh, look at
left
that.
side.
That's true.
So you can do multiple things. And this is a partial case, so we don't care about the right side of the patient, so we don't create a nerve channel here. We just move on. And in the meantime, let me point you here that there's this nerve channel definition tool on the workflow panel. And there is an extra thing here that's to define the diameter, meaning you want to make this thicker or smaller, you can change that. So, but in this workflow, we just use the default value. Now we finish the nerve channel, then we can move on to place the implants. Now let me repeat to summarize what we have done so far. We load the patient CT scan.
Mhm.
We load we do the thresholding of the CT data to create the lower jaw, and then we load the STL file of the lower jaw scan, do the registration,
Mhm.
load the upper jaw, create the nerve. Now we go to place the implants.
Mhm.
Now, when we place the implant, the first thing is to select the tooth number. For this case is 19. Then we find the implant we want from the library. Let's say, for example, we use Camlock.
Do we have AstraTech loaded on there? Because that's all.
We have AstraTech, for example. The thing is, we don't have their STL files. So if I choose Astra, let me go back a little. If I choose Camlock, I choose implant. I have their STL files, so I show the implants like that. But for AstraTech, we don't. So what we have is we will just show this. We don't have anything preview, and we'll create something like a cylinder. So let's say I'll pick this one.
Are we going to be able to have that? Because I mean, that's my go-to implant.
Oh, okay. So in that case, typically, this is how we, many of the time we work. So if we ask Astra for the STL files, they probably don't like to give us. So if you ask your salespeople to provide you the STL files for the treatment planning purposes and tell them to work with us, then they will. So
Okay.
just tell them. So now I pick this implant. Typically, as you know, we start from like 10, 11 millimeters. Then I will click on the implant site. So I have the implant here. Now, the next thing is we move the implant around so we can get a good position. So we move the implant, drag it, and we can rotate by the two handles here. And we go up and back and forth to check the position. And one more thing, if you look at this window and this window, we have these two buttons, like a cross-section of a CT. That's the cross-section display of this implant. So you go in here, if you rotate your mouse wheel, look at this white line here. This is corresponding to this cross-section. So this way we can check the implant around to see if it's good position with adjacent teeth and with bone structure, etc. So of course you can move the implant from here too. So you can drag the implant. You see here, we are also showing the sleeve on the surgical guide.
Yeah, I saw that.
So that's to place the implant and move the implant around. And of course, right now you can check the occlusion and to determine what's the best orientation you want to go out. So you can click this button again to finish that. Now, before we do that, remember I said this button? Let's say I want to record this video. First I make it bigger. I'll start recording. Then I'll rotate my view. I can also change the contrast on this view. I don't expect you to remember everything, but we can do all kinds of things. Then we say finish. It's going to generate a video file we call, let's say we create a test. Now, let me find where my file is. So this is my video file. This file is pretty big. Typically, we probably want to convert that. So in order to view this file, Windows movie player doesn't work actually. We would need something else, which is a very common. It's a free software you can get. That's called a VLC media player. You see here, I'm playing this video. So this way you can use a video to communicate the case. So that's a little bit about this video recording. Let's go back here. So let me exit this mode. We have the implant placed, and one more thing before we move forward. Look at here. It's the sleeve cut, barely touch the soft tissue, actually cut into a little, right? Mm-hmm. So that's not going to work if we make a surgical guide out of it. Correct. The thing is about the surgical kit. So for Astra, right now we don't really have their guided surgical kit information on the system. So what kit do you use for the guided surgery?
Astra. I mean, so we place Astra implants, we do some ankylose, right? But I'll say 95% of our implants are Astra.
So do they offer you the guided surgical kit with the longer drills?
Yep.
Okay. I probably need the information from you so I can put into the system. Right now we don't have Astra. If you look at here, we have ankylose, but we don't have Astra guided kit.
Okay.
So right now, let's say, if you look at here, we have so many kits. We have ankylose, ND, WD, and we have, for example, Biomet, Navigator, Camlog, etc. Typically for every single one, we have two options, with drainage sleeves or without. If you choose no sleeve, meaning you just want to print the guide, don't put it into the metal ring. Right? And we are offering a guided surgical kit. That's called GuideMia Universal Kit. For demo purposes, I'm using our kit here. But what we see here is by default, the location is not quite right. So meaning in this case, we need to adjust our drill length.
Sure.
So take a look at this. It says depth by drill length. If we go
to a longer drill,
23, it's going to move the sleeve up. So if we go 21, it goes, that was the original position, right? 21. So it's not enough, so we need to go higher, go 23. That's about the training height and the surgical kit. Mm-hmm. Then you also, for example, you want to place a virtual tooth here. Let's see. You go either create a tooth first and add the implants, or you add the implants, then create a tooth. It's both ways. So we click on this button and we find the tooth model. We use US numbering 19. You see the tooth is dropped to the location of the implant. And right now, let me close this one. I hide this one. So we see the tooth here. And of course, we want to move things around. We want to move it higher. So we can do all kinds of things to adjust the tooth. For example, we want to make sure is occlusion is about right if we want to do that. So we do this, and according to the current position, we may want to move the implant a little bit. For example, just to show the idea. Let's say now we want to move the implant according to the tooth. We move a little bit. That's something we can do with the virtual teeth and the implant. And take a look at here. When you have the teeth, you have the implant, you have lots of things around the screen. Then sometimes they overlap with each other. You want to, for example, lock the positions of the teeth, so only move the implant. So if, for example, here they are overlapping, what you can do is you want to use those buttons. You want to lock the teeth. Now you see the position tool of the tooth is gone. Now you can move the implant around. Or you can lock the implant, so everything is locked. Or you turn the tooth back on, so you can move the tooth. So that's tools to control what can be moved, what cannot. I'm going to turn on the implant back. So this way we finished one implant placement.
In this, are you able to adjust the tooth? You know, if the occlusion.
Yeah, of course. So actually, I wasn't planning to do so since you asked. Okay, on the toolkit bar here, let me move this toolbar to the lower level.
Oh.
We have a couple of buttons here.
Sure.
Touch up, local deformation, global deformation. So touch up meaning you want to modify the surface of the tooth model a little bit.
Okay.
Typically, we don't do that because that's for implant planning. We are not doing restoration design. But let's do it. So I do touch up. I click on this. I move my mouse back here. You see we have two more things here now. W means the width, the range of the deformation. That's 5 millimeters is too much. Let's say we only want to do 2 millimeters. And for each step, we want to do 1 millimeter, 0.1. So after we change that value, we move our mouse, let's say here, just to show you. We click on, press our mouse button here. You see here it goes down, right? So you make it deeper, for example, bigger. Or you can drag it up, use the Control key together with the mouse. So we move it up. So that's for the touch up of the anatomy. You can, it's like in a restoration design, you can do those kind of things.
Sure, okay.
So that's for small details, right? After you finish, you click this button again. What's more common is the next two, local deformation. I press on this button, you say we create a box on the tooth, but this box is too big. We use right button to move in and out. To zoom in and out. So and then we can rotate. And so what we do is we're going to drag this area. So if you look at here, I'm dragging this up. Right? So if you want to check here, for example, you double click this spot, then you go up. Then you can even go to other direction. So we can do that.
Okay.
That's the local deformation.
Okay.
Then you finish this global deformation. So there you see here, we have the whole tooth we have here. And what we do is we're going to scale the tooth along those handle directions. But the best thing we do is to first, we're not going to zoom this way. First thing we want to rotate the box so it's aligned with the tooth orientation. Then we make it bigger or smaller.
Mm-hmm.
So this orientation matters because if you go this way, right, and then you drag it, it's going to deform the tooth in a weird way. So that's how you do the global deformation of the teeth. Then you finish that. So that's to adjust the size. And also, if you want to change the color, you right click, change color, make it a green color so you can differentiate from the other part of the view. So that's how we do the virtual teeth and the size. Now, doctor asked me if you want to do immediate tooth extraction, what do we do? So let's say we assume this tooth 20 is immediate extraction. And we choose the tooth number 20. We choose an implant. Sorry. Oh, we choose the tooth number 20. We say, tell the system it's extraction. And we find the implant. Now I'm going to find something smaller. Then we add the implant here. So you only check this box, telling the system you want immediate tooth extraction. And now we place the implant around. I'm not going to spend too much time on the placement. So I'll just roughly drop it there. Now, for tooth extraction case, look at the sleeve we have here. So this is where the sleeve is. It's on the tooth area, but it's okay because we are extracting the tooth anyways. It's getting into the neighbor tooth. So I go to, I'll move this a little. So,
How would you? Okay. Go ahead.
what's your question?
Yeah, just with the sleeve. I mean, how would you know where? So if you have, like 19, we know that we want the sleeve not touching the soft tissue.
Right.
Now with this immediate extraction,
And it's got to be small enough to fit in between. All right, if you have two teeth, it's got to be small enough to fit in.
So a couple of things.
Yeah.
Well, you can get into the tooth. This is mainly by visual checking, right? You can get into the teeth, that's not a problem, but you cannot get into the bone level. So you need to visually check this. And of course, as the doctor just said, you cannot get into the neighboring tooth, right? So that's basically a visual checking. And there's another thing. After we finish the guide design, you will see. Right now, if you look at this line, I'm going to purposely mess it up a little. So we will see what are we going to get. So right now we place an implant, right? Then for the case we are not doing extraction, look at the first implant we did. So as we know, for the implant length is 11 millimeters, and the guided surgical kit typically has 9 millimeter extension, or we call it prolongation, right? Then you end up with 20 millimeters together, meaning from the bottom, the apical point of the implant to the top, that's 20 millimeters. Sometimes this is too low. So you got to tell the system 9 millimeter extension is not enough. I want something bigger. That's what we are doing here. We change the length of the drill because for guided kit, we have more different lengths of the drills. So when you actually put in your drill information, you will look at that. So we select the drill length according to determine the best position. But in fact, in our system, we can automatically determine the drill length. You don't really have to do so. When we are demoing or training next time, we use this workflow. I'll show you how it works. But right now, let's just do a manual setup here. So now we place the two implants. We go to next step to design surgical guide. But before that, I want to do a little bit more. This button to show the neighboring bone density. So the color shows the hospital unit value surrounding the implant. If I rotate the mouse wheel, it goes bigger and smaller, meaning I want to show a bigger area of the implant or the smaller area. So that we check the bone density surrounding the implant. So like, look at this, so we know here got more higher density, which is this part, and this area slightly lower, but in average, it's okay. So this is additional checking for the bone density.
Sure.
Now we go to guide design. Remember.
So one question, because you had mentioned way a lot earlier, right? If you have a patient that has a heavily restored, it's going to be a high scatter case. So
Yes.
Says, my description was, a patient who's heavily restored. We don't have 4 natural teeth, and it's going to be an immediate case. I mean, I don't have any other option but to just do a cone beam with what she has.
Yeah. In that case, if you are doing, in that case, we are doing radiographic guide for sure.
No, but there wouldn't be a radiographic guide because it's an immediate placement. She doesn't have any missing teeth.
Yeah, so this is something we are doing similar here. We still have this tooth, and we are extracting this tooth. So we use this extraction button. So I'm going to show you how the guide looks like. And as I said, I purposely caused some problem. We will see how to fix that. So let's go to next to design the guide. So you see how the surgical guide looks like. Let's ignore this for a while. We have the model. We have the 2 implants and the sleeves in place. And we're going to design the guide. A couple of things here. The first thing is to define the insertion direction. So meaning the insertion path of the guide, or in other words, we are surveying the undercut to determine the best orientation to insert the guide. Something like this on the screen. You don't want this way, you don't want this way. You don't want something like this in the middle, right? I look at the implant side. So we define this orientation in the first part. The second part is to determine the range, the area we want our surgical guide to cover. So we click on this check button. We typically will go more than half arch. Let's say we start from here. Remember this, never use right button in this view. If you want to add a point, click on the model. If you want to rotate, move the mouse away. So you cannot drag the model because it's going to add a point. So you always move the mouse away to add a point. Now we go here. We don't want to go to the back of the molar because that will make the patient feel uncomfortable. So we go here.
So with the guide design, you you're recommending half an arch?
Yeah, we recommend more than half of the arch. When it's too long, it might be a problem because some intraoral scanners they have a higher error. So if you do the full arch, sometimes it won't fit. I have seen a doctor presenting 3 cases from 3-chip intraoral scanner and from 3-chip software. So he said 2 out of 3 cases don't fit on the patient's mouth. So he actually ended up with modifying the guide. He didn't know if you modify the guide, you don't really know if it's right or not. You only know it sits on the patient, but it could be in the wrong location. So we wouldn't do full arch unless we are sure the scan is good. Typically, but if you go too short, let's say you go from here to 21 or something like 22, then the guide is too short. It's cannot provide enough support. So what we do, we go like half arch. We keep going around the case, the arch head points. So at the implant site, we go a little lower. For places with no implant, we go a little higher. And then we go back to the original point. Remember here, you go to the first point to close the profile. Now we define the profile of the guide. At this time, you can adjust it. Anywhere you want, you can adjust.
Okay. Now, one question. Let's just say theoretically, this person also needed to get implants numbers 29 and 30. Would you rather do 2 separate guides or 1 guide that goes all the way around?
It depends really. As I said, a couple of factors to consider. Actually, the first thing is if the scan is good enough. After we do the registration, we can check if the registration are good on both left and right side. Let's go back to do that a little later. So that's the first thing to check. The second thing is undercuts. We have gone through cases like that. So when you have, now this is a perfect case, right? The tooth is pretty much straight. There's no heavy undercuts here. But sometimes we see heavy undercuts here, both sides. So in that case, if you design the guide for the full arch, you could have a situation the undercut is too much and the guide setting is a problem unless you change the undercut value. In that case, you probably better off just do 2 guides. If not too much undercuts, and if the registration is good, we just do 1.
Gotcha.
Okay, now we finish the profile, and we click the. So as I said, 3 things: direction, profile, and we cut this area. If you look at here, we have multiple options. We can check the boundary as I just did, or I can do this circle thing. What this does is to use the screen to define a profile like a cookie cutter, so you can cut. So if I don't like this area, I have to reset. Now let me show you this. So I have to circle. This is, at this time we don't rotate the view. It's something like a cookie cutter. So I draw the profile. If you see here, I rotate the screen. It's not going to follow. What we do is we do this, and I couldn't put in the right position. Let's say we just do this. I'll cut. This is to cut along the screen. So you end up with something like that. Then you probably need multiple cutting. Then you go around again. then cut. This is not the way we recommend most of the time, unless you have to. So let's just reset this. We don't do that. Then we go back to this check mode. We go from here. So with this, we have a lot more control.
You recommend just going to the mid facial for the guide?
Yeah, for this, yeah, we can go, of course. We can go, of course, a little longer. It doesn't matter actually. Most of the time, probably we will go to this too. Okay. Now, as I said, you can drag everywhere. And then we cut this, so we get the guide area. So that's the direction, the boundary, and the third thing is to generate the guide. Here it asks us to confirm the surgical kit. We'll say yes. That's a little safety feature because sometimes the users may forget what surgical kit they choose, and they end up with the guide that's not for their kit. So we add this extra checking.
Will this software recognize if you have the wrong path of insertion? Would it tell you no, don't do that?
I'll show you something we have.
Okay.
It doesn't tell you that, but it will help. Okay. So after we finish the guide.
Okay.
Now I'll finish the guide. Remember I said I purposely made some mistake here.
Yeah.
Yeah. You see here, for the surgical guide, as we know, for immediate tooth extraction, this part, initially it has teeth, right? Then the guide will cover this area. After you cut, it's going to cut away this a big hole here, could be. And in order to fill the hole, we add this material. But for now, this material is added not barcolingually. Supposedly it goes to this direction, but it goes to this way. And if we, for now, if we look at the bottom of the guide, it's still okay. But it slightly might hit the neighbor tooth. Yeah. If this material is even more tilting to this direction, then we have trouble. Let's go back to take a look at what we have here and why I'm doing that. So I click on this planning. So I go out of the stage, go back to where I'm doing the design. So look at this view. Look at this material, this rectangle we added, right? And look at this yellow line. They follow each other. So for the implant placement, if you look at this tool, it has a circle, has a square, and it has this yellow line. On one side is longer, on one side is shorter. So supposedly this yellow line is for the hex orientation of the implant, and for the timing, right? And also for immediate tooth extraction, it's for the orientation to add this material. So it's important to make sure this yellow line goes about perpendicular to the arch.
Yeah.
Not like that. It's got to be something like this. So in this view, it's perfectly fine to rotate the implant like this because we are rotating around the implant axis. You cannot do this rotation here because the axis is the z-axis, not the implant axis. So it's very important. You can rotate this here any way you want to. It won't actually change the implant position.
Mm-hmm.
So we rotate that to fix this orientation, and then we go back to surgical guide design.
Yeah.
Now what you do here when you go back here is just click generate to regenerate the guide. So once you have defined the base model, the aerial for the guide, you can go back to modify implants, to change implants, delete implants, add implants, and come back just to click this button to generate the guide. You don't need to go through the first two steps.
So is this where you would refine the guide to add like windows, seating windows?
Yes, I'm sorry, what window?
Yeah, if you wanted to add like a window to make sure that it's seated all the way.
Oh, okay. Here, if you look at this workflow, we have this post-processing. It has a bunch of functions there. And for this work wizard dialog, we have one inspection button. That's what you need to do that. Now you see here, this material orientation is fixed. It's buccolingually. And now if you want to do inspection window, or if you look at the post-processing, we have an inspection window. We can add this tag. We can trim the guide. We can add irrigation window, add materials, etc. So all of those functions work the similar way. For this case, let's say we want to add an inspection window here. So all of them work the same way. You click to get into the model, the function, then you draw an area where you want to cut. Or you can go cut this way, or you can cut different direction, it doesn't matter. So you always go like that. So click enter the function, draw the profile, then finish. It's going to cut the window here. If you offer multiple post-processing functions, if you don't like them, you can click on reset. It's going to go back to the original design. So this way will help you to inspect how the guide is sitting on the patient's mouth.
Okay. Now, if you wanted to put an irrigation window.
Yeah, let's say for irrigation window, let's look at here. We go to this one. This irrigation window is by default is 5mm diameter. We click on this, click on the point where we want to add the hole. So we rotate this a little bit. Then you press again. It's going to add the hole here. Now that's the irrigation window. And if for guided for implant placement, for example, another thing we can do is to add a direction slot. So we click on this. Let's say we click on the first implant. This direction is used to help you to place an implant to determine the best orientation of the implant, the hex orientation. As you can tell, when we place an implant, our yellow line, the longer yellow line is probably this way. So we end up with this slot direction. If when we place an implant, we correct the yellow line direction this way, then the slot will go like that. So right now, this is not a perfect orientation, of course. Just to show you how it works, We click on the implant site, and then we finish the slot. It's going to make a slot on the guide, so you can, this can help you to determine when to stop rotating your implant.
Yeah, this is for the timing, yeah.
Yeah, this is for timing, yeah. Okay, so that's post-processing. Now, next, we can export the STL file and print with this button, and then we go to generate report. So before we generate the report, going back to Dr. Berger's question, is your system going to tell you if the timing is correct? I mean, if the insertion path is correct? So here's what we have. Let me maximize this window. I'll rotate this. So take a look at the back of the surgery. I right click on this. Here's the function, show fit analysis. It's going to show you how the guide will fit onto the patient's mouth. You see here is the white area is perfect match between the guide and the base and the patient's anatomy, basically. The tissue, the teeth, they are all perfect match. Now, look at here. This is undercut. So in the undercut area, we end up with some gap. If there's no gap, the guide cannot go in, right? Because it's undercut area. So this helps you to determine, to judge if the guide can sit on the patient's mouth properly. We can tell completely support on the lingual side. On the buccal side, the molar area, this two area is exactly matched. So guide sits very well here. Only in this position, there's a gap. Meaning when you actually do the surgery, this part is a perfect support too. You don't want to press this area on the guide. So a normal handling, you don't want to press here. It's going to tilt the guide because there is a gap. So that will help you to determine if the insertion path is correct. If we go back to guide design, get into a wrong direction to design the guide, for example, when we do the insertion path this way, then you will see lots of green area here, everywhere. Then you know that's a problem. It's not going to work because there's too much gap. Whenever you press this direction, the guide will tilt. So that will help you to determine that. I'm going to hide this fit analysis for a while. Now, let's go back to the design mode, planning mode of this model, this color model. System automatically generated that. It's called a virtual tissue model. What it does is to show us how well the model fit is registered with the patient. So let's go back to here. If you look at our workflow here, this is object manager. If you scroll down to the last, you see here this virtual tissue model. That's what we created automatically. If we want to manually create this, let me delete this for the moment. I can always click this and delete. Now let's go back to this workflow. Go to the first tab on here, this virtual tissue model. So by default, we show this model here. I can rotate the model so I can look at the tissue and look at the teeth. This is actually to define the insertion path, same as the insertion path function. But what we do is we rotate the view. So we look from the occlusion side. We forget about the text just here. Check this box saying the insertion direction is good. Then I will generate virtual tissue surface. So what the system does is to calculate the soft tissue and the patient's bone structure to find the tissue thickness of each of the spot. For example, here, the tissue thickness, let's say, is, look at here, it's about 2 millimeters, right? On this, let me double click on this spot. So here is the tissue thickness about 2 millimeters. That's the lingual side. So that's about here. If you look at this color and here, so we are showing the tissue thickness with colors, and we're showing this color bar, so you can map the color with the tissue thickness. So this way, we actually can do a couple of things. First thing is we actually can take a look at the tooth area so that we know the registration between the model and the patient CT is pretty well in those tooth area. Both buccal and lingual, they are all good. And another thing is, of course, we can tell the tissue thickness. Like here, we know it's a thicker tissue. And for radiographic guide, we will show you later. And but if you look at a case, when you see the virtual tissue model, if you see the one side and another side have a completely different level of thickness of the colors, basically, then it's a warning sign. For example, if you see everywhere yellow here and everywhere bluish here, then you know this either registration is not done properly, or maybe the tissue really got some issue, right? That helps you determine that. Another thing is what Dr. Fleming asked, if you want to have both number 19 and 29, for example, to place an implant, then we got to check if the registration is good on both ends. So you look at the right side, and then you look at the left side. For this case, you see here, we actually, across the arch, the registration is pretty good. So we know for this case, it makes sense if we make a guide cover the entire arch. But I really have seen cases, you just cannot do that. So the accumulated error is too much. Then you may end up with just make two guides. Now let's finish the report generation. We put a doctor's name here, phone number here. And if we go back here to this workflow, click on this, we'll put doctor information. And additional thing here in this interface is you can put additional diagnosis notes here or treatment plan notes here. Then you can put your logo file of your center and generate the report. Before I actually finish generate the report, I want to do a couple more things. So let's take a look at this implant. I click on this implant. So this is our implant. The first thing I want to add to my workflow is I want to check if I have enough bone on the buccal side. So I press this distance button. Then I'm going to measure the bone amount on the buccal side. And I'll do this on the lingual side too, as a practice. So that's one thing I want to do. Then second thing is I want to capture this picture. So to tell my prescription doctor or technician, whoever I want to tell, show them we have this bone amount. So I click on this button. On each of the window, you have this button like tag. That's actually to capture a picture. I click on this. Then I say to check bone amount, for example. Then I OK this. Where it end up with? Look at this workflow panel, this picture thing. Here we go. So we capture this implant picture. It's not just a picture. So I'll show you a little while. Let's say we capture the second one too. So the second implant we have, we capture the picture. It writes the comments here, truth extraction, for example. Now we have two pictures here. Remember I said it's not only picture, because when we go to somewhere else of this window, or when we, for example, we close the project, reopen it, we go into the system, I say, hey, Dr. Fleming, here's my treatment plan. I want to show you what I do and how is what's the reason we're doing that. So one way is I go to here, go to the implant, go to another implant. But the faster way is I go to this page, I double click this. It takes me right back there. That's a very interesting function. It helps you to communicate your case quickly. So you go back and forth, take a look at the situation. Then you double click the next. You go to the second implant, you go to the third implant, one by one. Or you go to, for whatever reason, for example, you want to show the tissue thickness, you capture this picture. Then
Oh, I see.
Then you get this here, right? Now, for example, I'm somewhere else. You double click this, you go back.
Mm-hmm.
So this is status. It's not just a picture. So this way you go back and forth, check your plan, communicate the plan with your patients or your doctors. Now, let's finish the report to see what we have in the report. Generate the report. Here is an additional safety feature. It says the surgical guide is out of date. Do you still want to generate a report? If you do, the report will not have pictures of the surgical guide. What does that mean? It means, remember, after we generate the guide, we rotate this implant a little, and we create pictures, we regenerate the soft tissue, we modify the insertion path by generating the virtual tissue model. So everything might have changed the plan. If we print the guide right now, it's not going to, it probably will not be the same as the report. So the system is telling you your guide design is out of date. You might want to redesign the guide, or if you generate a report, we are going to show you in the report the guide is out of date. So that's a safety feature. Let's finish this and come back to see what we have. Now we need to save the project. So we just create training. We say yes. Now we will generate the report. It's
Can you email the report directly from GuideMia? I saw
we cannot do that. I'll show you how we do that. We report it. We save as report tool, for example. So the report will be an HTML file plus a bunch of pictures. What you can do is to convert that into a PDF file. Then you can email the PDF file.
Right.
So we automatically bring up the web browser. Here's the report. Your logo will be replacing this picture. We have patient information, doctor information, disclaimer, and we got an area for doctors to sign. We got this X-ray mode of the display. The implant parameters, additional comments, surgical kit we are using, and anchor pins, if any. And then we'll tell you a list of the implants for the guided surgical kit, what's the drill length we're going to use. So this is the label on the surgical kit. And then look at here. This is a tissue-borne surgical guide. It's out of date. We keep telling you this because it's very important to make sure the guide is the latest design. And the guide has a timestamp on the software. We'll go back to show this. So we got cross-section views of each, and we got each implant will have 12 cross-sections. Very often doctors can just see the picture and tell you if it's a good plan or not. Now, last part of the report is the pictures we just captured. So we capture the pictures and we show everything here. You can consider those as additional planning notes or finding cards or whatever you want to call it. So they all end up with in the report. Now, nowadays, for many of the web browsers, if you do print, you can print as PDF. So you can end up with a PDF file which you can send to your doctors, to other people. So you can use this web browser printing function to print the report. Now let's go back to here. Basically, this ends our case. Just one more thing we didn't cover, but it's in the report. That's this X-ray mode. We can generate the panoramic view, and we can even adjust the threshold here. This is the panel picture. So this ends the case. Let's take a look at where is the data, and we need to cover a couple of things before we actually finish this case. So first thing, I got too many things here, so I got to we take a look at here. We got this PIE file, that's our project file. This IMG file is a temporary file. You don't have to worry about that. You never need to look at that. So this PIE file, and this is our report. As I said, it's an HTML file. It comes with an additional XML file. You don't need that. You never need that. So this file is a project. And they are, look at this file, they are very small. This file is very small. So it doesn't have the treatment planning data. Everything is here. It has the same project file name, training tool, and it has the files under that. So if you look at here, it got a bunch of files here. So what we do at the if you want to, for example, transfer your project data to me, you need this project file, the training.pie. You need the corresponding folder with training underscore files. You need this preparations STL file, antagonist STL file, and you need the patient CT scan. So that's why we say that we put everything under one single folder. You can just pack everything under this folder, send it to us or send to other people. So that's how you organize your project data. So this way we, as up to now, we finish this case. Let me see. You want to take a break so we can come back to a full arch case?
Okay, yeah, let's take a break.
How about 20 minutes?
It's up to you. I mean,
How long does a full arch case take to go through?
I think since we have gone through all the basics now, So the full arch case shouldn't take more than half hour.
Okay. All right, let's take how about a 15-minute break?
Okay.
All right.
All right. Let me see the recording.